Kia ora, Year 11 and 12. This video is going to look at some of the questions from that Logs and Exponentials unforgettably long homework worksheet that I gave you. I've picked out just 3 to do here, question 12, 13 and 7, and depending on your reaction I'll either not do any more or I can do some more. There are worked solutions up already, but in this video I want to talk through exactly what I was choosing to do and why. So all of these questions have got logs in them. The third one in here, question 7, has got the natural log, but that works in exactly the same way as a log to base 10 or a log to base 2. It was pretty funny how many of you freaked out when you saw this one, because this question really is just a level 2 excellence NCEA question. It's a disguised quadratic. And in this one we were giving our answer to 2 decimal places. In these two we were looking for exact solutions. So when it says exact solutions, it means don't give me any decimals, please. Just stick to fractions and integers. So I'm going to just crank through them now, and please do either email me with questions if you're in my class, or if you're watching this from somewhere else, leave me a comment and I'll try to get back to you. Okay, so let's start with this first one. We've got 7 to the power of 2x minus 4 brackets, which just means times 4 times 7 to the power of x plus 3 is equal to 0. Now the thing to notice in here is that this is 7 to the power of 2x and this is 7 to the power of x. And if you think about it, 7 to the power of x squared is equal to 7 to the power of 2x. So if we let u equal 7 to the power of x, then we get u squared minus 4u plus 3 equals 0. And we heave a big sigh of relief and solve our year something quadratic. So we've got u minus 3, u minus 1. We've got to be a little bit careful here, checking that we've got some solutions for x, not just for u, but we get u is equal to 3, or u is equal to 1. 7 to the power of x is 3, or 7 to the power of x is equal to 1. So for this one here, that's going to give me straight away x is equal to 0. 7 to the power of 0 is 1. And for this one here, we're going to take logs of both sides. So it's going to be x log 7 is equal to log of 3, and then x is equal to log of 3 over log of 7. And you can pick any base for that log, right? So we could pick base 7, or we could pick base 3. But we're chucking our answer into a calculator to get an approximate answer to 2dp. So we need to end up with x is equal to 0.56. So that's actually why I chose just the log to base 10 there, because I know that I want to go further and get an approximate answer. Let's see what happens if we chose base 7. I'm getting sidetracked, but hopefully for a good reason. So if we get down to here and we're choosing the log base, then if I go with base 7, we get a nice thing happening here, because that's just 1. 7 to the power of what gives me 7? 1. So we get x is equal to log to base 7 of 3. So if I'd asked you for an exact answer, that's a very nice exact answer, but it doesn't tell me much about the number. I can guess that 7 to the power of what gives me 3. It's going to be a fractional power, but that's about it. Equally, I could have done log to base 3, right? You get the idea. But if you want to actually get some real useful numbers, you want to be using either the natural log, ln, or just the log button, which is log to base 10. Okay, so that's enough on that one. So there are no weird things with conditions in there. Both of those values of x work, and you can check them back in that equation. Now in the next one, it's a little bit the same. There are 2 ways to do this next one, and I'm going to do the most efficient way and then another way, because they both illustrate log properties quite well. So what we were asked to solve was this: 2 to the power of x plus 4, 2 to the power of 2x plus 4 minus 9 times 2 to the power of x is equal to 0. So when I saw this question, I did it like this. I didn't turn it into a quadratic. I went 2 to the power of 2x plus 4 is equal to 9 times 2 to the power of x. And then I did my level 2 NCEA or my AS log rules. I took logs of both sides like this, and I got this. 2x plus 4 times log 2 is equal to log 9 plus x log 2. And if you think about, when you're doing logs problems, it's really good to think about like terms, right? So we've got log 2 here, and we've got log 2 here. And we can think of that x as being the coefficient of the log term. So that tells me that what I want to do now is collect up all of my stuff with log 2 on this side and get all of my constants onto this side. Kind of. So let's just go slowly. 2x plus 4 log 2 minus x log 2 is equal to log 9. Now my goal here is to get x equals blah, blah, blah. So we're going to have, let's see, 2x log 2 minus x log 2. Right, so that's cleaning up this bit. So 2x log 2 minus x log 2 plus 4 log 2 is equal to log 9. That gives me x log 2 is equal to log 9 minus 4 log 2. Now, at this point, it's fine. If you want to turn that into something like the log of 9 over 16, then that's cool as well. I left it like that because I can see some simplifying coming up. So then we get x is equal to log 9 minus 4 log 2 over log 2. And I can simplify that to log 9 over log 2 minus 4. Now, just one thing to notice that I don't remember any of you doing, but it's a really common mistake with early A-level students, or at least in my classes, is that it's not equal to this, right? So if you're still making this mistake, just go back and give yourself some really simple examples to do with little powers of 2 or 3, or ask me to give you make up some questions. Right, so that's, I think, the best way to do that question, or my best way. But the other way that you can do it is to do something like what we did in the first question, and do a disguised quadratic. So if you're not seeing what to do, a good strategy is to try and figure out if it's a quadratic. So let's go back up to here. We've got 2 to the 2x plus 4 minus 9 times 2 to the x is equal to 0. And we know that if we let u equal 2x, then 2 to the 2x is u squared. And we can split this power up. And again, this is kind of merit level 2 NCEA. So 2 to the 2x times 2 to the 4 minus 9 times 2 to the x is equal to 0. That gives us u squared, so 16u squared minus 9u is equal to 0. So this looks really easy, but it turned out to me to be just a little bit more work than what I did when I did it my way. So we've got u into 16u minus 9 equals 0. That gives me 2 to the power of x equals 0, so just shoving the u back, or 16u equals 9. So 2 to the x is equal to 9 over 16. So in here, there are no solutions to that equation, right? So that's not giving me anything valid. We need to reject. Here we'll take logs of both sides, and we get x log 2 is equal to the log of 9/16. And you can see that it's falling out how we had it before. And we can muck around with that and simplify up here if we wanted to. Okay, so that's those two done. I just want to quickly get through this last question. Where's it gone? Question, what one is it? Was it 7? Yeah, this one, question 7. So find algebraically the exact solutions to this equation. And there's a restriction on the domain. Now, the reason there's a restriction on the domain is that when we have a log or a natural log, any kind of log, we can't take the log of a negative number. So think about what logs are, right? If this is, oh, that's a terrible graph. If this is 2 to the x, then this here is log to base 2 of x. And you can't, because 2 to the x never gives you a negative number, when you have the inverse, you can't put in a negative number, right? You're switching the domain and range. But just looking at it in here, that's what's going on with this restriction. So they've told us x has to be between -1 and 2, but hopefully some of you are going, but why have they told us that? Well, they've told us that because that bit of the equation is going to not work when x is below -1. So for this bit, x must be greater than -1. But for this bit, and this bit, we need to have x not be too big. Okay, so all we have to do now is actually solve it, and then we're going to come back and check are my solutions in that range. It turns out one is and one isn't. I need there's some space. Okay, so a lot of you did this and got it right, but you did a ton of unnecessary work, which always makes me sad, especially when you've told me that the homework was very long. Looking at this, the first thing that I do when I see something like this is I put my log terms back together, right? We get really good at splitting them out, but it's good to be able to just shove them all back in together. So let's do that. Here on this side, we're going to have the natural log of 4 minus 2x times 9 minus 3x is equal to the natural log of x plus 1 squared. And then what a lot of you did is you started to try and divide this over here. And then you got a 0 coming in. So that made me cry, right? Because if we divide both, I'm just going to show you what you did. If we divide this on both sides, okay, OneNote just glitched, sorry. So if I go ahead and I divide on both sides, which is what some of you did, and you can do this, but you're just going to get yourself more work. You had this side as 0. It's not 0, it's 1, right? But anyway, we're not going to do that because that's just tons of extra stuff. All we're going to look at is we're going to say, well, hang on, we've got the log of this quadratic is equal to the log of this quadratic. And so we've got the log of a triangle is equal to the log of a square. All we've got to do now, we've got a problem that's really got nothing to do with logs. It's just to do with the argument of the log. So we're going to go ahead and solve a much simpler equation. The other way to think about this is we can e both sides, right? So we could do e to the power of this is equal to e to the power of this. So we're undoing both sides. But it's fine, you don't have to do that. We can just hop straight to equating the arguments. And we get 36 minus 18 minus 30x plus 6x squared is equal to x squared plus 2x plus 1. Be careful with your quadratics. Most of you did this really well. So 5x squared minus 32x plus 35 is equal to 0. Factorising that, some of you can do that pretty easily just by looking, and it falls out like this. If you didn't have that come to you easily, you could use grouping and you could do a factor tree. So we need the numbers to multiply to give me 175 and to have a gap and to add to negative 32. So we get 5 here and 35. You can see that the 5 and the 5 will give me 25, and there's the 7. So that's going to be my breakdown. Anyway, if you're watching this, hopefully you can factorise quadratics. Go watch the video on grouping if you're a little bit rusty. So we get down to 2 solutions. We get x is equal to 7/5 or x is equal to 5, but we reject this one. So this is the only solution. Okay, thanks for watching. That was already 13 minutes and that was only 3 of the questions. So happy to take your suggestions for which ones I should do next. I haven't marked the second half of the homework yet, but the first half is looking pretty good.